Welcome guys in this channel. So today I will cover two important concepts related to divide and conquer technique. So the very first one is selection procedure and next is Strassen's matrix multiplication. So let us start, and those who want to learn some other stuffs related to divide and conquer strategy, they can refer my previous videos. So these two are the last two concepts related to divide and conquer strategy. So let us start. Okay, so the very first one is selection procedure. So what is selection procedure? So according to the problem in hand, so input is given that an array of n elements and an element k. So array of n element is given and an element k is also given. So what is the output? Expected output is return kth smallest element in the given array. Okay, so take as an example, input is like a array which is having 10, 20, 30, 1, 2, 3, 11, 21, 30. So these are 9 elements. Okay, and one more element is given. Let us suppose here it is not written. K equals to uh, 5. Okay, so we are supposed to find fifth smallest element. So 11 is what? 11 is the fifth smallest element in this array. Observe carefully. So 1 is the first, second is 2 is second, 3 is third, and 10 is going to be fourth, and 11 is fifth. So this is given and this is also given. Okay, so this type of problem is there in hand. Okay, this is called a selection. So means we have to select the kth smallest element in the given array. So whatever the value of k is given. Okay, so what maybe the approaches? So the very first approach is what? पहले हम क्या कर सकते हैं कि मिनिमम फाइंड कर सकते हैं. फर्स्ट मिनिमम फाइंड करेंगे, सेकंड मिनिमम फाइंड करेंगे, थर्ड मिनिमम फाइंड करेंगे, देन केथ मिनिमम फाइंड करेंगे. ओके, बिकॉज वी आर सपोज टू फाइंड कि है ना केथ मिनिमम एलिमेंट. तो पहला मिनिमम मिनिमम फाइंड करने में हमें एंटायर एरे जो है ट्रेवर्स करना पड़ेगी. सो दिस इज एन टाइम, सेकंड के केस में n माइनस वन, थर्ड के केस में n माइनस टू, एंड लेट अस सपोज केथ के केस में n माइनस के. और अगर k की वैल्यू n बाई टू है, ऑलमोस्ट हाफ ऑफ द एलिमेंट पे अगर हमें रीच करना पड़ा है ना, ऑलमोस्ट. So it is nothing but n into k. So what is n into k? N into k is n into n by 2. Okay. So this is what? So n into k. So what is n? N into n by 2. So which is nothing but order of n square. Okay. So this algorithm, kind of algorithm. So this particular procedure is taking what? Order of n square time. Okay, so can we remove or can we reduce this particular time? Okay, so problem in hand, we know that array of an element is given and k value of k is given. So we are supposed to find kth smallest element. Okay, so we are very much aware that कि हमारे पास already एक algorithm है जो हमने quick sort में use किया है, that is partition algorithm. Okay, so there is one more algorithm, there is one more way which we can do. So this is order of n square. Next is, पहले हम sort कर लेते हैं elements को. तो sort the given array using merge sort, so it will take order of n log n time and go to the kth place directly, है ना, kth place and pick the element. So this is order of 1. So finally the entire technique, this particular two steps will take overall order of n log n time. Okay, so we reduced the time of this particular problem from n square to order of n log n. Okay, now let us see one more technique which can be used in this particular. So this is selection procedure. So ultimately we are using inside is what? Partition algorithm. So a is given. So a is what? A is array. This is array and this is start index of array. This is last index of array, and this is what? uh, kth smallest array. Is smallest. So this is basically value of k, uh, So it is value whose smallest element is found, whose smallest element to be found. Okay, so this is the these are the given things. Okay, now this particular thing overall from here till here, so this is what, this is the initial condition, because it is divide and conquer strategy. So always divide and conquer strategy क्या होता है, recursive program in nature. Okay, so initial condition, recursive program means first initial condition then recursive step. So initial condition में क्या है कि अगर p double equals to k है, only single element is there in the array, तो हम सिंपली चेक करेंगे कि क्या वो हमारा एलिमेंट है कि नहीं, जो हमें कंपेयर करना है। तो अगर p की वैल्यू k की इक्वल है, ओके, p और q अदर यू कैन टेक एनी, तो p और q की वैल्यू अगर k की इक्वल है देन रिटर्न a ऑफ p, बिकॉज a ऑफ p इज व्हाट, kth स्मॉलेस्ट एलिमेंट। अगर नहीं है देन एल्स रिटर्न व्हाट, -1। सो दिस इज व्हाट सक्सेसफुल, this is successful success, and this is what, this is failure. So this is the case of success and this is the case of failure. So this is initial condition. Now let us take if the problem is big enough. Okay, so what is problem is big, so big है तो then partition algorithm apply किया हमने a p और q में। Partition algorithm will give what, uh, so it places the chosen pivot element to its correct place, to its correct place। और we know what is the correct place, कि जो पाइवेट एलिमेंट चूज किया उसको करेक्ट प्लेस पे स्टोर कर देगा। ओके, और वो उसका इंडेक्स रिटर्न करके देगा। उससे जो भी लेसर वैल्यू है दैट इज ऑन द लेफ्ट साइड ऑफ दैट पर्टिकुलर प्लेस्ड पाइवेट एलिमेंट, और जो भी बड़ी वैल्यू है लार्जर वैल्यूज आर ऑन द राइट साइड ऑफ दैट पर्टिकुलर। ओके, सो नाउ जो इंडेक्स हमें रिटर्न करके दिया है हम वो सिलेक्ट करेंगे। अगर m जो हमें k सर्च करना है उसके इक्वल है, सो देन रिटर्न a ऑफ m, दिस इज आल्सो सक्सेसफुल। ओके, और अगर ऐसा नहीं है तो फिर या तो हो सकता है k की वैल्यू लेस हो या फिर हो सकता है ग्रेटर हो। लेस हो तो हमें लेफ्ट साइड में सर्च करना है, तो एल्स में अगर k की वैल्यू हमारी लेस है ना, जो भी पार्टीशन एल्गोरिथम ने इंडेक्स रिटर्न किया है पाइवेट एलिमेंट प्लेस करने के बाद, so if k is less than, then we need to search in left side, something like binary है ना search kind of thing। okay, so the means उस केस में हम क्या करते थे, उस केस में हम मिडिल एलिमेंट कैलकुलेट करते थे, इस केस में हम पार्टीशन एल्गोरिथम लगा रहे हैं। और सेम स्टेप्स जो है ये बाइनरी सर्च के, कि अगर जो एलिमेंट है जिसको हमें सर्च करना है वो अगर मिडिल पे ही मिल गया या जो पार्टीशन ने दिया है वहां मिल गया तो देन इट्स ओके। अदरवाइज लेफ्ट में होगा तो लेफ्ट हाफ सर्च करेंगे, अदरवाइज राइट हाफ सर्च करेंगे। सो दिस इज द केस। So k, if k is less than m, then selection. So what is selection? From a p m minus 1 हमें लेफ्ट में सर्च करना है एंड k को, और अदरवाइज सिलेक्शन a m plus 1 बिकॉज m is on the correct place, so m plus 1 q and k। So this particular thing will take if what the original problem of selection is having n elements, okay, and in order to find the kth smallest element the time taken by this selection procedure is t of n। okay, then the time taken by this particular half of the element is t of n by 2 and this t of n by 2। okay, so this is t of n by 2 and this is also t of n by 2, and this particular time taken by this particular algorithm is what, t of n। okay, and what about this partition? So partition is always take order of n time, already we saw। okay, and some initial steps is some sort of constant time, so let us analyze the time complexity। So if n double equals to 1 means only one element is there, then constant time। okay, otherwise if n greater than 1 then what, one half we need to select, so this is what, this is what for n by 2 elements, and this is what, this is the partition time, this is the partition. So let us analyze this particular algorithm. So this particular recurrence relation. So t of n by 2 equals to t of n by 2 and plus n. Okay. So now what is the procedure? So just you can solve anyway. So I am solving it by with the use of what substitution method. This recurrence relation. Okay. So t of n by 2. So it is t of n by 2 square and plus it is n by 2. And similarly, so this will be what t of n by 2 square and plus n by 2, and this we can write it as n by 2 raised to the power 0. This is 2 raised to the power 1. Similarly, if we repeat k times, then this will be n upon 2 raised to the power k, which is equals to 1, and plus, so like this, what n by 2 raised to the power 0 plus n by 2 raised to the power 1 plus n by 2 raised to the power 2 plus last is what? So here 2, here 1 means here k minus 1. So n upon 2 raised to the power k minus 1. Okay, so this way, uh, how we can calculate? So n upon 2 raised to the power k equals to 1, which is nothing but 2 raised to the power k equals to n. Okay, so 2 raised to the power k equals to n. So k is what? K will be log raised to n. So this is the value of k. So finally here is what? Here is t of 1 plus, if you take n as common. Okay, so this is what? This is, so 1 upon 2 raised to the power 0 plus 1 upon 2 raised to the power 1 plus 1 upon 2 square and so on, so 1 upon 2 raised to the power k minus 1. Okay, okay, fine. So finally, uh, if you solve this particular thing, so this is t of 1 is going to be 1 only and plus n, and this is nothing but a gp. So what is gp? 1 upon 2 raised to the power 0 and 1 upon 2 raised to the power 1 plus 1 upon 2 raised to the power 2 and plus 1 upon 2 raised to the power k minus 1. Okay, so this is half and half square and all. So ultimately this leads to 1, or if you apply the formula also, then it leads to 1. So what will be the resultant? 1 plus n. So here the formula is what? A. So what is A? A is 1 into 1 minus common ratio. Okay, raised to the power number of terms. So how many terms are there? K 0 to k minus 1 over k terms. So 1 upon 2 raised to the power k and divided by 1 minus half. So it is 1 minus half. Okay. So this is what ultimately this leads to 1 plus n. Okay. And this is what 1 minus 1 upon 2 raised to the power k is going to be n, 1 minus 1 upon n. Okay. And divided by half. So this, so in this way we can say the time complexity is what? So major term is n only. Okay, time complexity is going to be order of n. So this way. Otherwise you can solve it directly using master's method. So n raised to the power log a base b. So a is here 1, so log 2 is 2, so it is n raised to the power 0. So n is greater, that's the order of n will be the answer. Okay, so finally we can conclude that by using this divide and conquer strategy and specifically the selection algorithm, selection procedure, so this will take the problem will take what? Order of n time. So first we saw that order of n square, first minimum, second minimum, third and up to kth minimum. So kf n by 2, then order of n square. Second we saw by just sort the given array. So sorting, let us suppose by use with the use of merge sort algorithm, it will take order of n time. Then reaching to kth position, order of 1. So finally order of n log n, and finally with the use of partition algorithm, okay, in the selection procedure, so it will take order of n time. This is the analysis of this particular algorithm. So this is very useful and interesting algorithm, selection procedure. Okay, so it is having some practical advantages. Let us see how it is having. So this is a question. Okay, so question says that input is given an array of integers. Integers means z minus 0, z plus, means all the negative positive numbers including 0 also. Okay, and output is what? We are supposed to arrange the array in correct order. What is the arrangement? पहले नेगेटिव इंटीजर्स होंगे, फिर जीरो होगा, फिर पॉजिटिव इंटीजर्स होंगे. ओके, मीन्स हमें जीरो को उस जगह प्लेस करना है जिसके लेफ्ट साइड में सारे के सारे नेगेटिव इंटीजर्स हों और राइट साइड में सारे के सारे पॉजिटिव इंटीजर्स. ओके, so how we can solve this particular problem? Means as such as an example, this is like 100 minus 5 minus, so ये क्या है, मिक्सअप है सारा. ओके, तो हमें क्या करना है, जीरो को करेक्ट प्लेस पे प्लेस करना है ताकि लेफ्ट साइड में क्या हो, सारे स्मॉलर एलिमेंट, और राइट साइड में सारे कम. तो हम वी नो दिस काइंड ऑफ एल्गोरिथम. ओके, सो व्हाट इज द एल्गोरिथम यूज्ड हियर? पार्टीशन एल्गोरिथम. पार्टीशन एल्गोरिथम क्या करेगा? बट हमें जीरो को क्या सिलेक्ट करना पड़ेगा? जीरो को हमें एज अ पाइवट एलिमेंट सिलेक्ट करना पड़ेगा. तो पार्टीशन एल्गोरिथम ऑलवेज क्या करता है कि अगर जीरो को पाइवट सिलेक्ट किया है तो वो पाइवट को पार्टीशन एल्गोरिथम उसके, है ना, स्पेसिफिक प्लेस पे, उसके अप्रोप्रिएट प्लेस पे प्लेस कर देगा. तो जीरो से लेसर एलिमेंट्स लेफ्ट साइड होंगे और ग्रेटर एलिमेंट राइट साइड होंगे. तो दिस इज अवर रिक्वायर्ड आंसर. ओके, so find so firstly choose 0 as pivot element, find 0 as pivot element. तो 0 इस एंटायर एरे में हमें फर्स्टली सर्च करना पड़ेगा. सो 0 सर्च करने में, सो लीनियर सर्च विथ लीनियर सर्च. सो दिस इज लीनियर सर्च, linear search. Okay, and choose this particular 0 element as pivot and apply partition algorithm on 0 as pivot. So partition algorithm we know will take order of what? N time. So finally we can conclude that this particular algorithm, so it is overall 2n, so nothing but order of n. So this is the time complexity, this is the time complexity. So in order to solve this kind of problem, this is the time complexity. Okay, so this is very interesting and useful procedure, partition algorithm. So partition algorithm we are using a lot many places in practical situations also. ओके, अपार्ट फ्रॉम क्विक सॉर्ट एल्गोरिथम. क्विक सॉर्ट में तो पार्टीशन का यूज है ही, इसके साथ साथ कई प्रैक्टिकल सिचुएशंस में, ओके, कई प्रॉब्लम इन हैंड, इफ सडन प्रॉब्लम इज गिवन, देन we have a choice that we can use partition algorithm. So we know the power of partition algorithm, that if pivot element is selected, any element can be selected as pivot. तो पाइवट को वो करेक्ट प्लेस पे प्लेस करेगा, लेफ्ट साइड में लोअर और अपर साइड राइट साइड में ग्रेटर एलिमेंट्स. So this is the beauty of this partition. Let us see one more question. So there is a problem in hand that two arrays A and B are given. This is input. Output is find common element in both A and B array. So as an example, these two elements arrays are given. So what are the common elements in both? 10 are there in both. So 10, 20 and 30. Okay. So this how we can solve this particular problem with lesser time. Okay, time complexity is less. So let us understand, let us think how we can solve. So two arrays are given A and B, or common element we are supposed to find. So algorithm one, first algorithm is what? Apply linear search for every element of A to find some element in B. Means यहाँ पे हमने एक एलिमेंट लिया, इसके लिए लीनियर सर्च यहाँ अप्लाई की, अगर वो है वहाँ तो हमने आंसर में उसको, है ना, वी आर सपोज टू पुट इट इन आंसर. तो एक एलिमेंट के लिए लीनियर सर्च करने में वी में n टाइम. सो ओवरऑल n एलिमेंट्स है, तो n के लिए कितना लगेगा? ऑर्डर ऑफ n स्क्वायर. सो दिस एल्गोरिथम विल टेक, दिस पर्टिकुलर प्रोसीजर विल टेक ऑर्डर ऑफ n स्क्वायर, एंड दिस इज द फर्स्ट एल्गोरिथम. नाउ वन मोर एल्गोरिथम, we sort the given arrays A and B. So A को sort किया, ये आया आंसर. So sorting will take order of n log n time inverse, and B के लिए भी order of n log n time. Now अब इसके बाद क्या करेंगे हम? अप्लाई बाइनरी सर्च फॉर एवरी एलिमेंट ऑफ ए टू फाइंड सम एलिमेंट्स इन बी. तो इसके लिए फर्स्ट के लिए यहाँ इसमें बाइनरी सर्च लगाएंगे, तो बाइनरी सर्च विल टेक लॉग एन टाइम फॉर फर्स्ट एलिमेंट. सेकंड के लिए अगेन लॉग एन टाइम, थर्ड के लिए अगेन लॉग एन टाइम, तो एन एलिमेंट्स के लिए इट इज एन लॉग एन टाइम. सो फाइनली इट इज एन लॉग. सो फाइनली द टाइम कॉम्प्लेक्सिटी. So the time complexity for this particular problem is what? Order of n log. So we reduced up to some extent. So we reduced up to some extent because this first approach is taking order of n square time. Okay, and this particular approach wise, so with the use of sorting and finally applying binary search to each and every element of A, to find the similar element in B will take order of n log n time. Now, so this is the best approach, order of n log n time, because we cannot apply partition or some sort of things over there, because anyhow we are supposed to find each and every, but sorting plays an important role in this. Now, matrix multiplication, this is another important concept of divide and conquer. So if we don't use divide and conquer, means without divide and conquer strategy, then what will be the answer? So A is a matrix of size n by n, B is a matrix of size n by n. So if we multiply both the matrix, then we will get what? C of size n by n. So there is one important aspect which is related. So let us suppose A is a matrix of size I, suppose m multiplied by p, and B is also a matrix which is what? P multiplied by n. So this must be the same. They must be same for matrix multiplication. Same for matrix multiplication. Okay, so they must be same for matrix multiplication. Then what will be the final result? So C will be of size m by n. So this is the case. Okay, but here we are assuming all the elements are of size n by n. Okay, that is a square size square size matrix, square matrix. Okay, so what will be the procedure? So C of n by n में कितने elements होंगे? N square. N square elements are there overall. Every element require n time n multiplication. So n square will take what? N square into n, that is n q. So it is what? Order of n q. So this is the time complexity of matrix multiplication. Time complexity of matrix multiplication uh, without deck, without divide and conquer strategy. Now let us see how we can solve the same problem with deck. So using divide and conquer. So firstly, if the given array, given two matrices is less than or equals to 2 by 2. Okay, 2 by 2 का अगर है, then the problem is small, otherwise big. So what is the smaller problem or initial condition? कि अगर 2 by 2 का matrix है, then it is small, otherwise it is big. Like 4 by 4, 8 by 8. So assume, so this is the first point. Assume matrix sizes are power of 2. So what are power of 2? So as an example 2, okay, and 4, 8, 16, 32, 64, and likewise. So assuming that matrix size are power of 2. Okay, and next one is assume given matrices are square matrix. So this is the basic assumption. So this is the A matrix given like this. This is B given. Okay, so C. So this is what? This is A11, A12, A21, and A22. This is B11, B12. So these are 2 by 2 matrices, है ना? And B21 and B22. So जो हमारा C होगा, C में क्या आएगा? C will be here. तो पहले क्या आएगा? A11 multiplied by B11 plus what? A11 multiplied by B11 B12. So it is A11 B11 A12 or B21, A12 and B2, A12 and B. So this is the first element. Second element will be so A11 multiplied by B12. Okay. So this first row and first column. So this is the first element. Okay, A11 and B11, A12 and B2. Next, first row and second column. First row and second column, A11, B12, and plus what? First row and second column. So A11, B12 plus A12, B22. A12, B22. Okay, similarly, second row, first column. So second row, first column, A21 multiplied by B11 plus A22 multiplied by B21. And again, second row and second column. So what is second row and second column? Second row is A21 multiplied by B12 and plus A22 multiplied by B2. So this is finally the answer. So here if you are observing that, carefully observing that 8 multiplications are required, 1, 2, 3, 4, 5, 6, 7, 8, and 4 divisions are required of size n by 2. So finally this. Okay, so 8 multiplications. So this C11 is already I have written this. Hai na? So 8 multiplications are required, 1, 2, 3, 4, 5, 6, 7, 8, and 4. So all are size n by 2. So finally the recurrence relation is what? अगर n की size जो है 2 by 2 है, then it is small, so constant n. Otherwise 8 multiplications of size n by 2, and so this is what, this is the addition time. Okay, addition time. Okay, so this is the case. Now solve this recurrence relation using master's method. So you can solve using any method. Okay, so 8 t n by 2 plus n square. So what is master's method over here? I am writing over here. So master's method says this: t of n equals to a t n by b plus f of n. So according to that, n raised to the power log a base b. Okay. So if this is greater than f of n, then answer is n raised to the power log a base b. If this n raised to the power log a base b is less than f of n, then the answer is f of n. If n raised to the power log a base b equals to f of n, then the answer will be f of n multiplied by log of this. These are the three cases. So just apply. So n raised to the power log a is what? A is 8 and b is what? B is 2. So this is nothing but n raised to the power log base 2, and this is 2 raised to the power 3. So this is what? N raised to the power 3 log 2 base 2, which is what? N raised to the power 3. So this is greater than n square. That's why the time complexity is what? Time complexity is what? Order of n cube. So it is also order of n cube. So this is why using divide and conquer. So multiplying two matrices of size n by n using divide and conquer will take order of n cube time. Okay, but one mathematician, or you can say one researcher in the field of algorithm, named Strassen. So they reduces the multiplication, because multiplication plays an important role. So they reduces the multiplication to 7, means in place of 8 multiplication they use just 7 multiplication, and so addition. So there, in divide and conquer, normal divide and conquer matrix multiplication, in addition we are taking what, four additions, है ना. So they increases the number of additions, means 15 additions are there. But anyhow, whether you increase asymptotically, you increase any number of addition will always take order of n square time. Okay. So whether 15 20, so they उन्होंने क्या किया कि इम्प्रूव किया और इंक्रीज किया नंबर ऑफ एडिशंस को अप टू 15, and just reduced one, है ना, multiplication by one, so that is 7. So they given this particular recurrence equation. So 7 and here some 15, so no need of writing asymptotically, so order of n. So this is okay. So here this is what, t of n equals to 8t n by 2 plus n square. So this is what, number of multiplications. This, it is number of multiplication, and this is addition time. Okay. So here this 7 is what, 7 is number of multiplications. 7 is number of multiplications, and this is what, again the addition time. So just solve this. So n raised to the power log 7 base 2. So this will results n raised to the, if you calculate log 7 on the base 2, so this will gives n raised to the power 2.81. Okay, which is greater than n square. So that's why the time complexity for Strassens matrix multiplication is going to be what, order of n rose to the power 2.8. So this is no, very significant in terms of time complexities. Okay. So anyhow, Strassens reduces the time complexity of the divide and conquer strategy for matrix multiplication from n raised to the power 3 or n cube to n raised to the power 2.8, which is significant asymptotically. Okay, in algorithmic way. So finally, we are at the end of this lecture. So we covered two important aspects or two important concepts which comes under divide and conquer. So the very first one was divide and selection procedure, and the next one is matrix multiplication, and also saw the Strassens matrix multiplication. Okay, I hope you enjoyed this lecture, and if you are learning from the same, then like, subscribe and share this particular channel with your learning community. So all the best, happy learning to all of you, stay safe.